For this example, we're going to take a look at finding the intervals where a function is concave up or concave down and the inflection points. This time the function is an exponential function. So our function here we have f of x is equal to e to the 3x minus 9 times e to the x. All right, so taking the derivative of this, okay, one of the things that we notice is that right here for this part here, e to the 3x, this is going to be a chain rule. Okay, derivative. So I take the derivative of the outside, e to the 3x, and I multiply it by the derivative of my inside function, 3x, so times 3, okay, minus 9, and the derivative of e to the x is just e to the x. So the first derivative is 3 e to the x, or oops, 3e, 3e to the 3x minus 9e to the x. Okay. All right, now I'm going to take, I can't do anything to simplify that, well, other than factoring out a 3, but I'm not even going to worry about that. So I'm just going to take the second derivative. Okay. Again, this is going to be a chain rule, so I'm going to take 3 times the derivative of my outside is e to the 3x times the derivative of the inside, the derivative of 3x is 3, minus, and again, this is just going to stay 9e to the x. Just like that. Okay, so this becomes, for my second derivative, is 9e to the 3x minus 9e to the x. Just like that. All right. Now then, I want to, now for an exponent, the domain is all real numbers, so I'm just going to look for cases where my derivative, my second derivative is equal to 0. So this is 9e to the 3x minus 9e to the x. Now, one thing to remember, to keep in mind, so when we have e to the 3x here, that's the same as e to the x times e to the x times e to the x. So it means that what I can factor out in front on this function is 9e to the x. They both have that in common. So 0 is equal to 9e to the x times, well, I took 1 e to the x away. I still have 2 left over. So e to the 2x minus 1. All right. So now I can go ahead and I can set each piece equal to 0. So 9e to the x is equal to 0. Well, the thing to remember is that e is a positive number. No matter what I raise it to, no matter what I put in for x, e will always be, that exponent, it will always be greater than 0. So the thing to keep in mind here is that e to the x is always greater than 0, okay? So there is no solution to make this first equation true, okay? So now what I have to look at is e to the 2x minus 1, and where that is equal to 0, okay? So I'm going to add 1 to both sides, plus 1, okay? So I have e to the 2x is equal to 1. All right, and actually I'm going to move the 1 over here. This one there. E to the 2x is equal to 1. All right, so the problem is I have x trapped up in my exponent, all right? I need to somehow undo the exponential, undo the e. And the way that I do that, the opposite of e is natural log. So I'm going to take the natural log of both sides. Okay. That lets me know that, so the natural log and the e, they undo each other, and all I have left is 2x. And the natural log of 1, if you don't know what that is offhand, stick it in your calculator and you'll find out that that equals 0. So that tells me that x equals 0. This is my critical point. All right, so now that I have my critical point, I can go ahead, I can do, we had a lot of stuff there. I can do up my sign chart here. I have 1 point that I need to worry about right in the middle. Okay. It's a critical point and it's at the point 0. Okay. So I'm going to pick a point on to the left. We'll pick -1. I'll need to pick a point to the right. That'll be +1. And I am going to go ahead and I'm going to put those values into my second derivative. So the second derivative, if I put -1 into there, I have 9e to the -1 times e to the 2 times -1 minus 1. Okay, and if I were to go ahead and calculate that out, right, what I wind up with, this comes out to be approximately -2.86, okay, which is less than 0. So I know that to the left, my second derivative is negative. Okay. Now, if I take and I put 1 into my second derivative, so I have 9e to the first power times e to the 2 times 1 minus 1. Okay, and if I were to go ahead and calculate that out, this is going to work out to be, let's see here, approximately 156.3, which is greater than 0, okay, which means that on the right side, my function is concave up. All right, so, okay, what I know right now, so my function, let me write that a little bit better, is concave up on the interval 0 to infinity, and it is concave down on the interval -infinity to 0. Okay? Now then, because I change sign on my second derivative here from negative to positive, 0 is where there's an inflection point. Okay. So I know that my inflection point, so I put 0 back into my original equation. So I got to go all the way back to e to the 3 times 0 minus 9 times e to the 0. Okay, well, e to the 0 is 1, and 9 times e to the 0 is 9, which equals -8. So my inflection point is at the point 0, -8. And there are my answers for the intervals, whether I'm concave up and concave down, as well as the location of my inflection point.